Welcome! This video will take the PowerBasic Console Compiler code we prepared in our last video and add some advanced string handling, and also read from one file and selectively output to another. Now this is the code from our last video, which reads in text from a file and outputs it to the console. Tonight we are going to expand on this, and we're going to read from this file and output to a second file a selected amount of information. Now, to help with this, we have expanded on our data. We now have an extra column in our data set called iColor, and we've added a couple more rows. What we're going to do is to read each of the lines within this file and extract those lines that have a particular iColor and output the whole row to a new file. So, if we look at our code, the first thing to do is to decide on the name of the new file. So what we will do, we will create a new constant at the beginning of the program, which contains the name of the new file. Now, rather than change our existing function, we'll keep it there. We're going to create a new function. And we're going to call this new function read the file and output. As well as the name of the file to input, we'll want to actually add some extra parameters. We'll want to put in the column that we wish to interrogate. Just as a string. Then we will put the value within that column we're interested in. And then finally the name of the output file, which is our constant up here. So we're passing 4 parameters into this function now. So we might as well create the function. So in here we'll want to put the beginning of the function which contains the parameters, so we can define the parameters at the beginning. So there are our 4 values coming in, all strings, and we'll be returning a long value, just as we did in the previous function, which is basically a true or false. Right, so the first thing to do is to define some variables, much as we did the other night, which is going to be long file for the file handle. We're going to do a count, and we'll want to store the headers. So first thing to do is just exactly what we did in the previous broadcast. We're going to bring in this code here, and it's going to test to see if the file actually exists first. It will return false if it doesn't. It will attempt to open the file using a file handle defined here, and if we don't manage to open that file, we want to generate an error. So, if we do scan the file successfully, we will want to output the number of records, which we've read using the file scan command. And we will want to read in the very first line, which we know contains the headers. And there it is. Now, one of the problems with reading in any file is you assume the file format will not change. Now in this case we have 5 columns within this, and we're specifically interested in the last column. Now we could do what we did in the last video and effectively parse out based on column number 5. This would work fine until somebody actually changes the input file to have an additional column somewhere before the column we're interested in. So since the columns are actually named on the first line, we want to find out which column iColor actually is in before we interrogate the file. So what we're going to do in this one is we were going to work out how many columns we have. The easy way to do that, since we have the value of the headers in the string headers variable, we can quite happily output to the console using a new command we haven't seen yet called parse count. Now parse count takes as a parameter a string, in this case the headers. It also wants to know what the delimiter of that string is. Now we know it's a tab delimited file because we set it up that way. And since parse count returns a number and we're putting it to the console, we want to convert that to a string. So if we try running this now, it should attempt to read the file, throw out the number of records, read the headers, and we will want to put columns equals and the number of the columns. And finally, we want to close off the file handle, and should we have any errors, we will return false. And probably a good idea to output to the console. If we do get an error, what the error actually is. And assuming we get to the end here, the function can be equal to true because we've successfully got to this point. So if we try saving that, and we will run our program, we have got an error. Why have we got an error? We have not defined str header. The compiler has quite correctly noticed that we put in str headers and we're referring to str header singular. Now remember we had the dim all at the very beginning, which means you must dimension every variable before you use it. Now if you didn't put that in, if the compiler allowed that to happen, string header would have nothing in it and we would get invalid information, so it's good to actually pick that up. So let's try running it again now. The compiler hopefully has found all the errors. There we go. Number of records 11. There are 11 records in our file and there are indeed 5 columns. So the computer has now worked out how many columns we've actually got. So if we go back to our routine, what we want to do now is we want to interrogate each of the lines one by one until we get to the end. Now what we did in the previous routine was we put a while command in because we want to do a loop. And what this loop's going to do is it's going to loop until it's not the end of the file. So once it gets to the end of the file, it will drop out of this loop. And then for each line, we want to read the data in. And we'll put it into a string called strdata, which we will remember to define up here. And that strdata will contain the entire data line. Now we know we're after specifically the eye color. Now we know at the moment it's going to be column number 5. So what we'll do initially is we will test the value of column number 5. So we use the parse command on strdata, and we know it's a tab delimited file and we're interested in column number 5. Now if it equals, and we were wanting to go for whatever we get in for the column value, so there we go. We're actually testing the value of that string, 5th column, looking for the value we passed in, and if it actually does that, we'll just put it out to the console for the moment. And what we will do, we will put out the entire data line to the console. So if that match is not found, we will put nothing out to the console. So if we try running that now, there we go. We have pulled out 3 values, 3 columns rather, each of which has matched the brown eye colour we were looking for, and it's put them out. So it's quite happily interrogated the file, pulled out the information we wanted, and put it out to the console. So what we wanted to do in addition to that was be a little more clever about working out this value. So the question is, how do we work out the value? Well, since we know the headers contain all the values, what we want to do is to pick out that value. So in order to do that, we need to find out what that value is. So what we're going to do is we're going to create another generic function. And we're going to work out what that column value is going to be. And we're going to put the value, in this case it will be a number, not a string. And we'll slot the number in there, so that will contain a number. Now, up here when we've actually got the headers, this is where we want to work out what that value is going to be. Now, we need a way of actually working that out, so we're going to create a brand new function. Very useful, can be used all the time, and we're going to call that fun_parse_find. And it's going to get some values. It's going to return a number. So what we're after is the string we want to interrogate, which in this case will be string headers. We want to give it the delimiter, which we know is a tab, and we want to tell it what we're looking for. Now, we knew what we were looking for because we passed it in as a column name, so we'll put the column name. So there's our function, or the call to our function. We're going to call fun_parse_find, give it the headers, give it the delimiter, give it the thing we're looking for, and it will return a number. And that number can then be used as a replacement for the number 5. Now, we have to create this new function. So let's go and create a new function. This is a useful function to have because you can use it for lots of things. So start and end function. Now we know the headers is going to be a string. The tab we will put again as a string. We'll just call it delimiter, I think. And I'm using the underline character to fold the line down to the next line so it's easier to read. And we'll have column name again as a string. Now, how are we going to pull off this remarkable stunt? Well, the first thing we want to do is we want to actually find out how many columns there are. Now we worked out earlier how many columns, we'll use the same logic. So we'll set up a little counter, and what we're going to do, we'll put try in just for the fun of it. And what we're going to do now is we're going to do a for next loop, which is basically telling the computer to work out which column it wants to look at. So it's starting at column number 1, assuming there is at least one column in it. And we're going to use parse count again. And parse count is going to look at the string we've passed in, which in this case is the headers. And it's going to take the delimiter, which in this case we know is going to be a tab. And a for next loop basically will go until there is nothing more to do. So should anything error within here, we're going to, in this case, return 0, as in it didn't find anything at all. So as long as this actually gives us a value, then we'll know it's a column number. If it gives us 0, then there's no column number. So for each of the values in here, what we want to do is we want to check using the parse command of our str headers, str delimiter, and the element we're looking for is driven by this long R, which will be, in our case, between 1 and 5. So the first time running through this loop, it'll be 1, then 2, then 3, then all the way up to 5. Now, the search criteria we're after is held within this column name. So if the value on any of the columns matches whatever our column name is, then we know we found the one we're looking for. So at that point, the return value of the function is going to be the column number, and at that point we don't have to go any further, we can exit the function straight away. Now we know based on our own data that it will get all the way to the last column before it returns, but should somebody shuffle the columns around in the input file so the eye colours first, it would find it straight away. So assuming we've actually keyed all this right, this parse find should return a value of 5. Now if we go back to our original code, which is fine, we're passing eye color and we're passing brown. Now I have a sneaking suspicion the eye color column has actually got a space between eye and color. Yes, it does. So let's just change that to eye space color, otherwise it would not match. I wouldn't find anything. Now what we're going to use in here is we are going to use the debug functionality, which we'll find is very useful within PowerBasic. Now we're fairly sure of the code up until this point. This is code we've not actually tested yet. So just to test this is actually going to work correctly, if you press the F9 on any line, it makes it go bright red. This is a breakpoint. The breakpoints can also be set from your tool menu up here. Under debug, you'll find there's a toggle breakpoint. If we press it again, it goes off. If we press it again, it goes back on again. Now it means if you put a breakpoint in here, the program will actually stop in debug mode at that point. We go back to the main program and we press the bug icon, which lets us compile and debug the current file. Now it's throwing a wobbler. Ah, yes, it's quite correctly syntactically saying I didn't put the word as in. Debug again. And I didn't do it for the next one either. I'm doing remarkably well here. Why is it complaining? Ah, spelling mistake. Right, okay. Now we've got the bugs out. Oh no, it's still moaning because I can't spell. I'll call it delimiter. Is it delimiter? Right, hopefully we run that now. Yes, of course I want to save it. Yes, and it's forgotten my file. Recent file. That one. Right, okay. Debug. Right, okay. Now we're running debug. As you'll see, the line it's sitting on is the first line in the program, which is bright yellow. Now, since we know we put a breakpoint in here somewhere, put a breakpoint on. If we go back and we hit the F5 button, it will step through till we get to a breakpoint. So what it's actually done here is it stopped here, so we can actually look at the value. If you right click on the variable, click on watch, it shows you the value. First name, tab character, surname, tab character, address, blah blah blah, all the way down to the end. And the column name we're actually after is eye color, which is great. So if you F8 into that, it will step into the function. If we bring long R up, we watch that one, it will then quite happily tell us it's 0 at the moment. If we F8 that, it's now 1. and we'll see if it matches. No, it doesn't match, so it keeps going. 2, 3, 4, 5, and it has found it. It's found it on the 5th column. So long R is going to be returned as 5. There we go. So if we look at the column number now, watch that one, there's the value 5. So it's quite correctly picked up the value 5, which is exactly what we're after. So if you want to just continue to the end of the program now, we could hit just the F5 button and it will throw out to the console 11 records, 5 columns, and they were the 3 we're interested in. So even if the eye colour was moved to a different column, it will now correctly find it regardless of where it is. As long as we get the name of the column correct, then the column could be anywhere within the file. So that touches on Debug, very useful tool. We go back to our main program. What we want to do now is we will want to output that data to a separate file. Now, in here where we display it on the screen, this is where we would want to actually do the output. Now, rather than individually hand coding a piece of code to handle every single one, another generic function is likely to be a good way of doing it. So what we can do with that one, we can create a new generic function, and what we're going to do with this one is I've prepared one we did earlier, and I'm going to paste this one in and explain to you what it actually does. Now, this is a function I'm calling append to file. It takes 2 parameters. It takes the file to add to, and it takes the data to add to it. The idea behind this is you can call this function multiple times, and if the file already exists, it will just append to it. If the file does not exist, it will create it. So on this one, it's basically again getting a file handle, next file handle from the system. Again, with using the try catch just in case there's any errors. It's testing to see if the file already exists. If the file already exists, then it's doing an open, name of the file for append. Remember the one we did before was to read a file. We're now actually appending to a file. And we're using a lock shared approach, as in we're putting a lock, but we're letting other people read the file while we're writing to it. Otherwise, if the file doesn't exist, then we're opening it for output. And then all we're basically doing is a straightforward print to the file handle for the data we passed in and returning true. Should some error occur, then we're returning false, and eventually we're actually closing the file. So if we take this line here, steal it out of the program, go back up to our program in here, if we can find the line, that's the line we were actually wanting to output. So what we're going to do there is we want to append to the file. Now we haven't told it what file to go to, right, but we did pass in the file name, which is a file we want to output to. So that's quite straightforward to paste that one in. That's what we want to output, and the data we've got is in fact str data. Str data contains the entire record. Now we can actually test that. Because this call will return true or false. So what it's going to do here is going to test to see if we've successfully managed to write to the file. If we can, we'll put a field to output to file, and if we do, it will put record written. Now, assuming we coded all this up correctly, what it should do, it has field to output the file. We've done remarkably well here. How have we managed that? We never specified the directory. So what we'll do in that one is we will specify exe path at the front of that. Now that hopefully should allow us to run. No, it still doesn't allow us to run. Why is it not allow us to run? What do we call the file? We called it output file.txt. Well, that's fine. Why is it not outputting? False. Append to file. To file. Add to open file by add to for pane lock shared. File. I think we need debug in this one, to be honest. We will put our debug in there because obviously it is returning false. And we will find out what that error actually says. So F5 on it. Permission denied. Okay, it's giving us a permission denied for some reason. So the question is, where is it trying to write to? It's trying to write to myfile.txt. Ooh. Which is our input file. It's trying to write to the input file. So let's have a look at, we're giving it output file. Oh, I think we've picked the wrong file here. Yes, yes. If we go back to our read file and outputs, yes we are, it should be the output file. We've picked the wrong variable. There we go, the program has quite correctly picked up the fact that we made a mistake. So now we're pointing towards the right file. It has indeed written 3 records to the new file. And if we have a look at our output file, there's our output file. The 3 records it's actually found. Now to be tidy, we probably want to put the header in there as well, just so you can actually read the thing inside Excel or any other program. So what we'll do is we will go back F2, go to our function again, and I think what we will do is up here, once we've got the headers, we will then steal a little function, paste it in there, and what we're putting, rather than the data line, we're putting the headers to the output file. So if we run that now, it should write out quite happily. Now the only thing we didn't think of is that we're not clearing out the file before we start. It will just, since the file still exists, it will continue to append to it. So this gets us to another bit of file handling magic. What we can do in here is, since we're running this read file and output, the one thing we'll want to do before we start is to ensure that the output file doesn't exist. So we're going to do another try. And we're going to use the kill command. And we're going to attempt to kill the output file to make sure it doesn't exist. Now the reason I'm putting it in a try catch one is that the very first time you run this program on a machine that doesn't have an output file, then it would in theory error if you try and wipe it by killing it. So in this case, we're not bothered if it actually errors, because its only error could be that it can't actually wipe the file. So let's try that now. Run the program. It says it's written 3 records. If we have a look at the output file, there we go. It's put the header in, it's put the 3 data lines in, and it's stopped at that point. And if we run it again, it would do exactly the same thing. And it's no longer, it kills the file first before it writes to it. So what we've done in this video then is we've read from one file, we have programmatically pulled information out based on a parameter, in this case iColor, and we've written the data out to a second file. So I think that completes the work for this particular session. Thank you for watching.